Dear students, this is the fifth slide of inverse trigonometric functions. In slide 4 we have discussed the example 1, and this is the rest part of example 1. For x less than equal to 1 greater than equal to 0, let y is equal to sine inverse x. Therefore, y belongs to close interval 0 and 1, because sine inverse 0 is 0, sine inverse 1 is your 1. So, it is 0, 1. So, the y belongs to 0, 1. So, we have your sine y is equal to x. Therefore, cos y is equal to root over of 1 minus sine square y is equal to root over of 1 minus x square. Therefore, y is equal to cos inverse root over of 1 minus x square. The value of y is the sine inverse x is equal to cos inverse root over of 1 minus x square, as we have discussed earlier. Here tan y is equal to sine y by cos y. So, the value of sine y is x and cos y is root over of 1 minus x square, where x is not equal to 1, because when x is equal to 1, this will be something by 0. Therefore, y, since tan y is equal to x by root over of 1 minus x square, y is equal to tan inverse x by root over of 1 minus x square. But you know y, the value of y is sine inverse x. Sine inverse x is equal to tan inverse x by root over of 1 minus x square. Then cot y, here x is not equal to 1. Cot y is equal to cos y by sin y, root over of cos y is root over of 1 minus x square, sin y is x. This implies y is equal to cot inverse 1 minus x square by x, where x is not equal to 0. So, the value of y is sin inverse x is equal to cot inverse 1 minus x square root over by x, where x is not equal to 0. Again, sec y is equal to 1 by cos y, 1 by root over of 1 minus x square root over. That root over of 1 minus x square. So, y is equal to sec inverse 1 by root over of 1 minus x square, where x is not equal to 1. The value of y is sin inverse x is equal to sec inverse 1 by root over of 1 minus x square, where x is not equal to 1. Then cosec y is equal to 1 by sin y is equal to 1 by x. Therefore, y is equal to cosec inverse 1 by x implies your y, the value of y is sin inverse y is equal to cosec inverse 1 by x, where x is not equal to 0. So, we have discussed sin inverse in other forms, in other trigonometric functions, as we have discussed that cos inverse root over of 1 minus x square, and sin inverse x is equal to tan inverse root over x by root over 1 minus x square, cot inverse root over of 1 minus x square by x, sec inverse 1 by root over 1 minus x square, and also your cosec inverse 1 by x. For the second part, this is the second part of example 1. Example 1, for x less than 0 greater than equal to 1. Here in first part we have discussed x is less than equal to 1 greater than 0. Here we prove that sin inverse x is equal to minus cos inverse root over of 1 minus x square is equal to tan inverse x by root over of 1 minus x square, where x is not equal to 1, is equal to minus pi plus cot inverse root over of 1 minus x square by x is equal to minus sec inverse 1 by root over of 1 minus x square, where x is not equal to minus 1, and is equal to cosec inverse 1 by x. Proof. Given x is less than 0 greater than equal to minus 1, let x is equal to minus w. Therefore, w is greater than 0. and W lies between 1 and 0. Therefore, x square is equal to W square. Then sin inverse x, in place of x we can write minus W, sin inverse minus W, which is minus sin inverse W is equal to minus sin inverse W is, since W is positive, cos inverse root over of 1 minus x square. So sin inverse x is equal to minus cos inverse root over of 1 minus x square. Since your W square, replace for W square we write x square, because x square is equal to W square. Then sin inverse x is equal to minus sin inverse W is equal to minus tan inverse W by root over of 1 minus W square is equal to tan inverse minus W by root over of 1 minus W square, because tan inverse minus theta is equal to minus tan inverse theta. Tan inverse minus theta is equal to minus tan inverse theta. Then it is equal to tan inverse, in place of minus W we write x to root over of 1 minus x square, since W square is equal to x square. Here x is not equal to 1. Again sin inverse x is equal to minus sin inverse W is equal to minus cot inverse root over of 1 minus W square root over by W, which is equal to minus cot inverse, we have multiplied minus in numerator and denominator, that is minus root over of 1 minus W square by minus W. But because we know cot inverse minus x is equal to pi minus cot inverse root over of 1 minus W square by minus W. Here minus is there, minus bracket pi minus cot inverse root over of 1 minus x square by minus 1 minus W square by minus W. That is minus pi plus cot inverse, that is 1 minus W square is 1 minus x square, in place of minus W we will write x. So we have sin inverse x is equal to your minus pi plus cot inverse root over of 1 minus x square by x. Again sin inverse x is equal to minus sin inverse W is equal to minus cos inverse 1 minus W square root over is equal to minus sec inverse 1 by root over of 1 minus W square is equal to minus sec inverse 1 by root over of 1 minus x square, where x is not equal to 1. Again sin inverse x is equal to minus sin inverse W is equal to minus cosec inverse 1 by W is equal to cosec inverse 1 by minus W, because cosec inverse minus x is equal to minus cosec inverse x is equal to cosec inverse 1 by x. In place of minus W we write x. So we have converted sin inverse to different forms when x less than 0 greater than equal to minus 1. By the example you see here, sin inverse half is positive here, so we will take the first part of the formula, that is cos inverse root over of 1 minus x square, that is cos inverse root over 1 minus 1 by 4, x is 1 by 2 is equal to cos inverse root 3 by 2. If we will simplify this, is root 3 by 2 and is equal to tan inverse x by root over of 1 minus x square. X means half root over of 1 minus 1 by 4, that is tan inverse 1 by 3 is equal to cot inverse root 3 is equal to cosec inverse 2, because sin inverse 1 by 2 is equal to cosec inverse 2. If we take sin inverse minus half, that is equal to, here x is negative, that means x lies between 0 and minus 1. So we have this minus pi by 6 is equal to minus cos inverse root over of 1 minus x square. We put the formula 2, that is tan inverse minus half by root over of 1 minus 1 by 4 is equal to tan inverse minus 1 by root 3. This much. In the next class we will discuss example 2.